Welcome to the fifth and final quick start guide for the Neo Blockchain Toolkit. This series has been intended to get you quickly up and running using some of the key functionality of the toolkit. We've also got some full tutorials available that will walk you through the end-to-end process of building your first real-world Neo smart contract, and links to those tutorials are in the description. In this specific video, I'll show you how to step through Neo smart contract code in a debugger. This will allow you to identify issues in your code using tooling that you're probably already familiar with. I'm going to open Visual Studio Code and open the folder that we created in the previous Quick Start video. Unlike the previous videos, I'm not actually going to start my private instance of the Neo blockchain this time. That's because debugging smart contracts using the Neo Blockchain Toolkit doesn't actually require a running blockchain. The debugger runs the Neo virtual machine in process, and any blockchain level details, things like the signer of a transaction and contract storage, are emulated by the debugger. I'll load up the test invoke file that we created in the last quick start. And I'll also load the source code for our Hello World smart contract. Shortly, we'll use the Neo debugger to step through the code in this smart contract. The debugger allows you to use all of the functionality that you'll be used to if you've debugged in VS Code before. Things like setting breakpoints, watching variables, and stepping line by line through code are all possible. I'm actually going to click next to line 23 here to put a breakpoint right at the beginning of our change number method. There are a couple of ways to launch the Neo debugger within Visual Studio Code. You can launch the debugger directly from the invoke file editor, or you can add a debug launch configuration to your VS Code workspace. Let's start by looking at the invoke file editor. I'll go back to my test invoke file. As you can see, we have a single step in this invoke file. It's the same as the one that we created in the last video. It invokes the change number method and provides an argument of 42. I'm going to press the debug this step button. I'm asked if I want to specify a signing account for the transaction. This is technically optional, but if you have any code at all in your smart contract that depends on being run as part of a signed transaction, then you will need to do this. And as you may recall from the previous video, we do have code in our smart contract that performs a lookup using the address that signed the transaction. And that's because we let each individual Neo account store its own unique numerical value in the blockchain. So I'm going to click yes to this message, and now I'm asked to select an account. The invoke file editor allows us to easily select any of the accounts in our Neo Express configuration, and it's listing the Alice and Bob wallets that we had created previously. I'm going to select Alice, and we're debugging. We immediately hit the breakpoint that I added right at the beginning of the change number method, and the debugger has been paused. At the top of the debugger pane, you can see the variable inspector, and it's been populated with my local variables from the change number method. You can see positive number has already been initialized to 42 as it was provided as an argument. You can also visualize the storage for the contract, but that's empty right now. In the middle of the debugger pane, I can add variables or expressions to watch as I step through the code. And below that I can see my call stack. Let's step through some of the code. I'm just going to press the step over button a few times. You can see that after I stepped over line 33, the storage for our contract became populated. The hex string here is the hex key that has been generated by the Neo runtime for the key that we just added. And if I expand it, you can see the key is a byte string representing 20 bytes, and these 20 bytes are actually the 20 bytes corresponding to Alice's public key. And the item is a single byte, 2A, and that's the hexadecimal representation of 42, the value that we provided. I'm going to keep stepping through. And after line 35, you can see that the VS Code debug console contains a notification to inform us that our smart contract fired an event. And then after line 38, we see the return value of our smart contract method, which is 1. And 1 is just the integer representation of true. And the debugger has exited. That was a fairly simple example, as our smart contract is quite simple. I'm just going to do some quick refactoring. I'll pull our validation logic out into its own helper method. Let's call it validate number. I'm going to build my code. Now I'll go back to my invoke file and launch the debugger again. This time let's use Bob's account. You'll notice that the contract storage is empty again. That's because any changes made to storage when debugging a contract are not persisted when the debugger exits. Later on, we'll explore a method for simulating pre-existing storage when debugging smart contracts. So again, we've paused at my breakpoint at the beginning of the change number method. I'm going to step over that. And this time I'll use the step into button to step into our new validate number helper method. You can see the variables list has been updated, and it's now only showing the variables local to the validate number method. And also the core stack now has an additional frame, and as you'd expect, I can click on any frame in the core stack to view the state of the local variables for that particular frame. I'm going to step out of the validate number method and then just press continue to let the debugger run to completion. You can see the output similar to before in the debug console. Our contract fired an event and then exited, returning the value 1. Next, let's look at how we might debug an error condition in our smart contract. I'm going to go back to my test invoke file, and I'll add a new invocation step. I'll pick our hello world contract again, and I'll pick the change number operation. This time I'm going to specify -42 as the argument though. If we were trying to submit this invocation as a transaction to an actual Neo blockchain, it would be rejected. I'm not going to do it right now, but feel free to pause the video, start your private blockchain, and try running this step just to confirm that. I already tried earlier and I know that this invocation fails, so I'll go straight into the debugger and try and figure out why. I'll use Alice's account. Notice that I have the uncaught exceptions checkbox checked in the VS Code debugger panel. This means that the debugger will automatically pause whenever my contract throws an exception that has not been caught. I'm going to try stepping over the validate number method. And you can see that the debugger has automatically paused at line 25. It's alerting me that an exception has occurred. This hopefully would make it obvious to me, the developer, why my invocation is failing. In this case, I'm providing a negative number to a contract that's been written in a way such that it only accepts positive numbers. I'm going to press the continue button to let the debugger run to completion, which happens immediately because we just threw an uncaught exception. You can also see a message in the debug console alerting us that the Neo virtual machine ended in a fault state, and it explains to us why. I mentioned earlier that there are 2 possible ways to launch the Neo debugger. You can also add a launch configuration to your VS Code workspace. Let's close our invoke file and explore this other approach. I'm going to click Create a launch.json file in the VS Code debugger panel. And now I'm presented with the different environments that my installation of VS Code is able to debug. I'm going to select the Neo contract option. VS Code has automatically created a launch.json file for me. This is stored in the .vs Code folder in my VS Code workspace. Because my workspace only contains one contract, VS Code is automatically filled out the program field to point to my compiled contract, and it's given my launch configuration a name based on the contract name. I do still need to fill out the operation name and the arguments though. One disadvantage of the launch.json approach is that I don't get that helpful autocomplete assistance for operation names and arguments. I have to remember those details myself. The advantage of this approach, however, is that I can specify some additional, more advanced debugger options. For example, I have this storage property where I can specify what pre-existing storage items should be emulated by the debugger. Let's add a dummy value just so that we can see this in action. Check out the link in the description for documentation about other parameters that can be specified in these launch configuration files when debugging Neo smart contracts. So I'm going to save this launch.json file. And now I have a new entry in the run list at the top of the debugger panel in VS Code. I'll select that menu item and press the Start Debugging button. And again, we're debugging our Neo smart contract and we're paused at that first breakpoint. This time though, you can see that our contract already appears to have some data in storage. If I expand out the storage node in the variables panel, we can see one item in storage, and it's that 3-byte string corresponding to the text foo, and the item corresponds to bar. I'm going to press continue, and again the debugger is automatically paused because we've thrown an uncaught exception. I'll press continue again to let the debugger run to completion. So there you have it. You've now created a Neo smart contract and know how to debug it. For a walkthrough of some more real-world examples of developing Neo smart contracts, remember to check out those tutorials, and links are in the description below. Thank you for watching.